Hey guys, hope you guys enjoyed your weekend. What we're doing this week is paper chromatography. Now, chromatography is an analytical technique that's used to separate out substances based on their polarity differences. One of the important things that we're measuring this week is an RF value. Now, an RF value, also known as a retention factor, describes the ratio of time spent in the stationary phase relative to the time spent in the mobile phase in the basically in the difference distance traveled by the compound divided by the distance traveled by the solvent, and it determines exactly what that RF value is. So what we're looking at is, if you see this piece of paper, I actually have three of them set out with three different colors. So if you look at them, you can see that this one is black, this one's green, and this one is blue. Now, we're going to be putting these in water, and so the water is going to be below this line, this pencil drawn line, because the pencil is not going to travel in the water. So it's going to be a measure of the distance that the water is going to travel and bring these uh, these compounds through, and that distance that it travels based on how far the solvent, which is water in this case, has also traveled, that ratio that we're looking for, that's going to be our retention factor. So now that I have these three strips of chromatography paper, which will be already cut and laid out for you, I have three beakers of water. So what I'm going to do is, one of the best ways is you take your piece of paper and you're going to just like bend the very top of it, and you need to bend it based on how tall your beaker may be. So it may need to be bent a little bit differently. You take it and then you're just going to rest it into the water, so that way it doesn't fall down. So you can just do a rough estimate and kind of bend it over the lip this way, and then you'll just stick it in and bend that lip. Okay? And so we're going to do that with all three pieces of chromatography paper into our solvent or our water. Now, the key thing is to make sure that our water is not below that, the water is not above that pencil mark line, because if it's above it, then we have no way of measuring our spot distance, the distance that our spot traveled, based on the distance that the solvent traveled, because then we have no way to measure from that line, because if the water is above it, so you need to make sure that that line is well below or well above that solvent line, or the mobile phase. So it's going to take a few minutes for the solvent to travel up the chromatography paper. So while you're doing that, you can be thinking about the procedure too. And this is where you're going to be coming up with sort of a creative solution with ink, and seeing if you can get a message across to someone without it being completely apparent, sort of like a James Bond move. Or if you want to see, all right, if I got ink on my shirt, how's the best way to get that ink out without ruining the actual color of the shirt, based on the retention value factor for that ink or that shirt. So just be thinking of some ways to do that. You can think of them beforehand, and that way you'll come into lab and you've got a little bit of an idea of what you're trying to shoot for. Once you get into lab, if you want to bounce your idea off of your professor, then go for it. I'm sure they'd be happy to help you. Hope you guys enjoy your lab.